but there is a lot of research and recent research on ear development, seed size, and when all that energy transfer takes place in the plant, and how we can affect the size of the kernel. So it's called Corn Yield Finished Right, focusing on kernel fill time. So first of all, we understand there's a lot of difference in genetics. So hybrids that flex mostly in kernel depth must be managed at the end of the season. Kernel depth occurs during the last 30 days of grain fill. So a long grain fill period is beneficial. We've all seen that. We've seen hybrids flex as much as 30, 60 bushels in depth alone, kernel depth alone. Kernel depth needs water, it needs nutrients, it needs sun, it needs it all the way to the end of the growing season. We have seen, especially in the south, that spraying fungicides tends to add yield, because when disease is not present, the stay green effect actually increases ear fill and kernel depth. So this is the premise, you know. So the impact of kernel size, we have a little chart here, and we can see the impact that kernel size has on grain yield. Here, planting at 32,000, 16 kernels to the row, 35 kernels, 16 kernels around, 35 kernels to the row. Here's what we would receive. 100,000, 100 kernel weight, gram being 25 at 15.5% moisture, we see a variation between 179 bushels all the way to 256 bushels. So this is a significant portion of yield that we need to understand. So the grain fill stages in corn, the grain fill period begins with successful pollination and the initiation of kernel development, and ends approximately 60 days later when the kernels are physically mature. We know this. And during that grain fill, the developing kernels are the primary sink. And when we say sink, that is the destination of those sugars, of the current photosynthetic process photosynthetes the sugars that are being produced by the plant on a daily basis. So this photosynthetic demands, the sugar demands of the developing kernels, will take precedent over that of much of the rest of the plant. We've seen that the negative effect we see on plants that are poorly fertilized. The plant will accumulate dry matter into the kernels, sometimes at the expense of the health and maintenance of other plants and lower stalks. We've seen this, we understand this. So silk emergence is technically the first recognized stage of the reproductive period. See, every oval potential kernel on the ear develops its own silk, the functional stomata of the female flower. And the silk remains receptive to pollen grain germination for up to 10 days after soaking. Really, it's that first 5 days that we really want to focus in on. It's generally not the number of pollen, it's the synchrony and also the size of the pollen that would have an impact on the number of silks that would be pollinated, and the number leading to the number of potential kernels on that ear. So that takes us to the R2, that kernel blister stage. This is a little sequence of development. About 10 days after soaking, we see that we have the blisters, what we call the blister stage, R2 stage. Tip kernels are generally last to be fertilized. They're less vigorous than the rest, and they're more susceptible to abortion. Kernels are most susceptible to abortion during that first 2 weeks following pollination. And that abortion, as stated, would occur primarily at the tip of the ear. Now, once the kernels have reached the dough stage, R3 stage, of development, further yield losses will occur mainly from reductions in kernel dry weight accumulation. So we don't see that we have loss because of abortion, but because of seed size and seed weight. So about 18 to 20 days after soaking, this is our R3 stage. Sometimes it may be up to 24 days. Starch continues to accumulate in the endosperm. The endosperm cell division is nearly complete, and continued growth is mostly due to cell expansion and starch accumulation. So this kernel dough stage, R4, about 24, 26 days after soaking, the kernel's milk changes. We have this doughy consistency because we see that starch is starting to accumulate in the endosperm. Kernel abortion is much less likely to occur once kernels have reached early dough stage, but severe stress can continue and have an impact on the yield. So there's a connection to the development of starch, the accumulation of sugars transformed into starch, that you get to the point where abortion is no longer likely. So dent about 31 days to 33 days after soaking. All the kernels are denting near the crowns. And here's the key point that we want to take. More importantly, kernel dry matter content at the beginning of R5 is only 45% of the eventual final accumulation. So there remains approximately more than 30 days before physiological maturity occurs. So it's been said and understood or said by many farmers, I've reached dent, I'm out of the woods, I got a crop, I made my crop. In reality, only 45% has been accumulated. So there's a lot of activity that's taking place that can have a 55% impact on the final yield of that crop. So finishing up the agronomy side of the plant, about 55 to 65 days after soaking, kernel weight, dry weight reaches maximum, and kernels are said to be physiologically mature. And the only way we can really receive loss is if we have lodging. So that's what will affect lodging, will affect yield after R6. Now, this is a very interesting part. Now we're going to go into the biology. That was the agronomy side of the corn plant. Now we're going to go into the biology of the corn plant. First of all, we have to understand the primary objective of that plant is the formation of viable seed. That's what the plant wants to do. That's what it was created to do, to form a viable seed. Now, in order to do so, it needs synchrony of growth and development of the endosperm, the embryo, and the seed coat. Now, when we look at this, we see that the seed coat is part of the maternal tissue, the mother plant. The endosperm and the embryo are not. So this is called the Shannon hypothesis, and it's been updated. It's been in biology books for quite a few decades. What we also want to note is, and we're just focusing in on sugars because there's many things that are transported to the grain. There's phytohormones, there's enzymes, there's minerals. There's a whole bunch of things that are transported to the developing seed. And that transport gate, that BETL, which is the basal endosperm transfer layer, is so important. we can think of this like a developing baby in the womb. The mother has its metabolism, it has its own circulatory system and all that stuff, and the baby too has a system. And the nutrients come through the umbilical cord, but nutrients only flow one way. Sugars only flow one way. They don't flow back out of the embryo. They do not flow back out of developing fetus back to the mother. So what we see is focusing in on sugar is that the sugars, and there's various sugars, sorbitol being one, sucrose is another one, and there's other exotic sugars that are just being explored that are so instrumental in the rate of the movement of sugars into the developing seed kernel. So as that sugar comes in, it is converted into starch. So the rate of conversion of sugars into amylose, into starch, it has a significant impact on the size and development of that kernel. The gateway, this BETL, this basal endosperm transfer layer, is also important. So we need to understand this biology in order to, how can we affect this basal endosperm transfer layer so that we can move more material quickly, and how can we affect the conversion of sugars into starch within that plant? If we can affect that, it is noted that the length of grain fill is important, but the rate of grain fill is as important or even more important when it comes to grain size and grain weight. So this is kind of an important concept to get our heads around a little bit, that the first thing that we need to understand is what that plant wants to do is to form viable seed. Also, in the study of epigenetics, this BETL, this basal endosperm transfer layer, comes into play because epigenetics is how life inherits its own unique variation of the genes that it came from. So as we know, it's more than just direct gene transfer. There's a variation, and then you try to influence that variation by, well, a lot of times through hormones and also through environmental influences. So this is the biology piece that we need to understand, and as we're trying to make an impact on this corn yield. So sugar transportation within the corn plant, we know that chloroplast in the cells, what this does, this is talking about photosynthesis. So this is what this is about. Then we have this plasmodesma. This is these little, they're actually like little channels, they're like little wires that actually transmit signaling molecules across that. So we see that from photosynthesis, we have energy that's locked up in sugar molecules. It moves into the cell walls. It has a pathway, a transmission way in order to be transported into that. So it all ends up that most of the sugar is moved to the phloem part of the plant. That's the living part of the plant, the living cells. It's surrounded by a lot of companion cells, a lot of sieves, a lot of tubes, and the remaining phloem, this sieve tube in which we have reduced cytoplasmic content, there are openings on both ends. So this opening allows this transportation of sugars either up the plant or down the plant. It can move in two different directions to the growing point. Meristematic tissue and leaves can move to the growing points in the roots. So sugar transportation within the corn plant is what we're talking about here. Now, not only is the transportation, but the concentration of sugars also has an impact on it. So what happens is, as the water from the xylem, those are the pipes, the tubes that move up from the roots that carry water, as there's a higher concentration, it creates pressure. And so we have pressure involved in movement. And all of this is based on the diffusion principle to guide the movement of sugars within the phloem. So the diffusion principle divides the movement of sugars within the phloem. This is basically that source sink model that we talk about. Now, in pre-flowering, there's a change here. In pre-flowering, sugar movement to the growing points at the apical meristem, that could be the root tips, or could be the end of a leaf or a branch or whatever. Okay, those roots is caused by tying up or binding it with cellular respiration, or tying it up with sugars in a more complex molecules, such as starches, or the development of cellulose for structural strength and integrity of the plant. These sites become the sink for diffusion of sugars from the source, the leaves. So we understand this basic understanding of the source, the leaf, and the sink, various other growing points of that plant. This is pre-flowering. It's all based on the diffusion principle, which is based on the concentration of sugars in the phloem tissues in regards to the uptake of water to the xylem tissue. So we have the transportation. Now, how about the translocation? So we have it in the phloem.
Hey, John.
How do we translocate it?
John?
Yes.
Sorry, I was going to wait.
Yes.
I had a question put forward. I was going to wait till the end. I thought maybe go back to
All right.
What does BETL stand for?
That's basal endosperm transfer layer.
Okay. We can go back to it after
Okay.
for review, but just.
Yeah, we can go back. Let me see.
Oh,
Yeah, right here. Right here. This little layer here. This is what separates the viable seed developing, the seed development, the baby from the mother. Okay, and nutrients can only move one way. Nutrients, hormones, sugars, enzymes, there's hundreds of things that move, and it only can move one way. It can't move. Once it moves into this developing seed, those sugars cannot be reabsorbed into the plant. Where other tissue, like sugars moved into the stalk, can be translocated out of that stalk to the developing plant. So
John,
mm-hmm.
is there in this particular scenario, does the xylem and the phloem both feed the kernel? Or is it just the phloem?
It's the phloem. The sugars are in the phloem.
Right. Okay. So water isn't part of this equation.
No, water is part of it, because remember what we talk about.
It's moved through the phloem then. Okay.
It's the principle of diffusion,
mm-hmm.
but you need the pressure. The water provides the pressure to move it.
Okay.
That's why we understand this. This is why we talk about turgor pressure. We talk about potassium. We talk about potassium moving sugars. Well, when it's moving, is not direct, but it's the pressure. It's the turgor pressure that's causing the diffusion of those movement of those sugars into the sink. Without that, you have no movement. You have no push behind it to move the sugars.
So this is the faster way of it moving into the kernel. This way.
Well, what we're
through turgor pressure and otherwise through diffusion. Is that what you're saying?
Yeah, that's what we're trying to do. This
Yep.
is naturally occurring. So how can we impact the speed? Because the accumulation of photosynthetates is primarily based on sunshine. So it's based on a daily schedule. There's so much is accumulated in the daytime. You have respiration at night. You have movement, and so all of this comes together. So I know it's a little complicated, but I wanted to go to the agronomy side of the plant, and then we have to go through a little bit of biology to understand why we've come up with this. This is a little complicated. So we have the concentration, the diffusion principle, movement, source, sink. We have now the translocation. So once after flowering, the kernels become the new sink. Remember, the sugars that enter kernels cannot come back out. So these new sinks actually start to compete with the root sinks. We see that. We know that around R3, the roots cease to grow. Why? Because the kernels are demanding the sugars, and they are being translocated to the kernels, and they compete with the root sinks. Genetics comes into play, the strength of which determines a lot of the strength of the sugar demand, the number of kernels, affects the total draw of sugars. It's like if you had a bank of lights, if you had 1,000 lights and you turn on one, you draw so much current. You turn on two, you turn on 1,000, you got a lot of draw. And that's what that's about, the numbers. Here's the point, the strength of the pool of sugars. So it is the demand, it is the sink, the strength of the pool that is in control. It's not the source. So the strength of the pool of the sugars per kernel also involves in the efficiency of the kernel to removing sugars to make more complex molecules such as starch. So we have that pool, and now we have to speed up that process, the efficiency of removing those sugars. That's that efflux, the discharge or the outflow of those sugars, converted into amylase, hidden away in that kernel so that the kernel has a deficit of sugars demanding more sugars. So it increases the strength of the pool of the demand of sugars from the plant. So it's in the phloem tissue, we have the pressure, we have all this stuff going on. We have the movement of sugars in the phloem is directed by the pressure-driven bulk flow principle of moving from high concentrations to low concentrations. I know this is could be a little overwhelming, but I want people to really understand that what we put together is not BS. It is based on science. It's not based on any magic at all. So,
hey, John.
Yes.
So there's another question in the chat.
Okay.
I'm just going to say to anybody on the line here, if you do have a question, just go ahead and ask as you have them. It's probably more timely than putting it into chat. So Jeff, do you want to ask your question?
Yeah, so what I was wondering, you said a little bit ago, John, that once the sugars go into the kernel or into the baby, as you were saying, that they don't flow back out. But the high yield guys like to harvest at that maybe 27% moisture because they found that they can lose bushel weight if they let it dry down too far, even after black layer. So what's happening there when they lose that bushel weight?
It's probably it's not sugars. It's not starch. You can't move. So it's probably water. I'm not sure. I would have to.
When they dry it down, it doesn't lose it. So it can't. How can they dry it down to 15.5 with a dryer and not lose the bushel weights? But if they leave it in the field, they lose bushel weight.
All I do know is the understanding of just like an embryo develop or a fetus developing, you know very well, you can abort it, but you can't absorb it.
Cows reabsorb aborted embryos all the time.
Yeah, but after it's dead, it's no longer
Right.
part of the function. So it's like absorbing a tumor, you know. So I don't know. I don't know, but that is a good question. I can try to find out.
Yeah,
But
I've never heard of harvesting early to preserve yield. If anything, as the kernel develops and matures more naturally, it you know, it retains and improves test weight.
yeah, I do know that they harvest at 30%, which is the high yield guys, which is, you know, and they spend money on drying it down. But you know, once the black layer occurs, there's no movement. As far as all the research, all the universities I've ever read, and you know, I'm not a biologist, you know, but I do read their literature, but it says that's the end of any movement of nutrients. The only thing it's lost is water through evaporation drying process. But it's a good question. I can research it a little bit, you know.
Well, depending on
Okay.
who's in on Thursday, they'll question with that, in my mind.
Yeah, and I'm glad you brought it up because this is a practice thing, and we want the message to be accurate. That's why we're running it by you, and I can change this, even though I speak with confidence. It is not, you know, I will carry the water. Whatever message that we need to carry is what we want to do, because this is all about sales. It's not about teaching biology. So
I think that the item that comes into question, and I don't mean to walk into the conversation, but there's a broad assumption that the corn has black layers, and I think that is a really unknown definition in growing corn today. If, you know, a lot of people, black layer may or may not happen on a lot of these crops. And the US model on grain harvest is always to leave it in the field till it's shriveled up and dried down and not pay any moisture. But I think it deals with whether that absolute black layer has happened or not. And, you know, John, you're working on in the biology side is that black layer absolute has happened. I would challenge that there's a lot of varieties out here that aren't black layered when harvest is happening. And that's been an ongoing thing with finish in a crop for my whole career, whether it was 80 bushels of corn or 300. Anyway, my 2 cents worth. There was Purdue's work that was done a few years ago with yield loss, probably did more identification of the fact that we weren't in black layer, and that absolute maturity had not happened on the plant.
yeah, and I agree with you 100%. A lot of it is because of the genetics have changed, and they have a lot of the stay green genetics in it. And you know, it was to affect the vegetative part of the crop, but those genetics also have a tendency to prolong that development or the potential development. That layer, the abscission layer, isn't formed. I remember reading that some time ago. So I agree with you, you know, 100%, you know. So I can tone that down a little bit. Just someone send me a note so I don't remember what I say, but just to tone it down, and then I can stay off of that. Okay. If that's better, Jeff, for you, you know, like I said, this is about sales.
Yeah, I really like Ray's explanation. I think that's hitting the nail on the head. It's probably we don't understand where black layer is, And that,
Okay.
instead of just looking at it on the bottom of the kernel, maybe it's still not there yet. And that's probably the best thing I've ever heard on that topic.
So
Yeah.
in the classroom today, within the body of the group of you, you have everything from Ed having, unless you got 2 inches overnight, Ed, which I don't think you did, you have 0 rainfall in Ed's environment. You have close to the plant here, 4.5 to 5 inches. On general, 1.5 inches last week. Rick, I think you're 3/4 to 2.5 across the market. So in the body of that, as we approach pollination, as we approach reproductive stages, Ed is set up probably, irregardless of what the final yield is, Ed is probably setting up to actually have absolute black layer on his crop strictly because of the stress that crop is going to go through. Whereas if you get, and again, I know nothing. All I know is if we get a shot of rain on these stay green varieties at the wrong timing, our sinks reverse a little bit. We don't outpull the kernel, but we seem to take on growth back into that root ball, which is a challenge. And, you know, dry weather stress, Jocko's not on here, but when we're in the West, if we want a mature crop, we drought it, turn the water off. And I think we're battling that. I think the high yield people have identified that if they take it with a non-confirmed black layer and they dry it, then they can capture some of that leakage that goes back out. So
Yeah.
anyway, that's just me.
And that makes sense because those are all irrigated fields that do that. And so they have a tremendous amount of water on those fields. And with that stay green, you're going to have a tendency to still produce cytokinins in that plant, instead of, this is based on cytokinin production being over within the first 10 days. It may prolong even though it's at a reduced rate, which would have an effect on that BETL layer. So that all makes sense what you said. I mean, that makes sense because we don't, like you said, we don't really understand black layers. A lot of it depends on the genetics and also the environment that was grown in. I've seen it in other crops. As you talk, I visualize it. So, but it all makes sense. All right. Do you guys want me to continue a little bit? I only have a couple more slides on the biology. So the biology of corn plants after the initial 10 days of movement of glucose or sugar in developing kernels, it's really consistent with nearly all hybrids. So as the corn embryo develops, the cytokinin accumulation in the pollinated ovule after the first 10 days. So there is a constant translocation of sugars to each kernel for each day. So that first 10 days is more or less genetically driven, okay? But the total daily movement continues for about 40 more days. So almost regardless of the daily variable rate of photosynthesis due to cloudy weather, leaf damage, disease. So there's a continues for 40 days. So how do we speed up? How do we move more sugars? How do we convert those sugars into starches? How do we increase the metabolism or the rate of conversion? So sugars are drawn from the leaves, as we know. They are stored in the stalk pith tissue. We know that. The total draw of the ear is determined by genetics. We talked about it, environmentals, minerals, number of kernels. The number of kernels is determined by genetics, environmental, minerals, and water. Water available during the pollination is very critical. So the daily transfer of sugars during days 50 to 60. This is that proverbial black layer that's been changing with the genetics. The daily transfer of sugars during days 50 and 60, the last 10 days of grain fill, is frequently reduced until the abscisic layer acid effects causes thick cell walls to form at the base of the kernels. So, as you mentioned, they're harvesting before that. They're harvesting it maybe a week to 10 days before black layer. And this all makes sense. Okay, and it's because cutting off the sugars transfer into the kernel and the movement of water from the kernel, this is known as black layer. So the consequences. Okay, sugar translocated to the ear or sugars not available to other living tissues of the plant. That's a consequence. Roots are especially dependent on the same sugars to support metabolism functions, including warding off potential microbial invaders. Starving roots, as they rot, eventually reduce water uptake, and if insufficient water to meet the transpiration rate from leaves, a permanent wilt will occur. So we get this wilt, and with the wilt, movement of sugars to the kernels is stopped. Abscisic acid takes over, causing the black layer to form a base on the kernel. The consequences is light grain affected and on the affected ear. So that's the consequences. The solution, we have come up with a product called BioLine Nexus. It's designed to enhance crop to finish right, energy balance, sugar transport, key nutrient support, electrolytes. It's empowered by dynamic nutrient exchange and superior cell permeability. BioLine Nexus intensifies the utilization of applied nutrients by the crops. And the timing on corn, we like to see 1 liter applied at VTV R1, that window. That is going to reduce abortion. And then at R3, R4, which will have a great impact on seed weight and seed size. Similar on soybeans during that reproductive period, R3, and also at R5. So thank you. Any questions?
So,
Did I lose you?
no, still here. You know what? Everybody can unmute and ask the questions. So unmute all.
So does their Nexus have GA in it?
No.
You wouldn't want GA in it, Jeff,
No.
unless you wanted to absolute end everything.
When John was talking earlier, he was talking about the cell sizing, and I thought, well, maybe GA would be important at that time to help size the cells. You know, in that in the blister stage, in that early part.
No, it doesn't. It's basically it's based on a lot of our BioLine technology, and it has nutrient support with key disaccharides that are used to go back to this. Let's go back to this right here. To impact the rate of uptake, and also to impact this conversion of sucrose into starch. And so that's the key. So the more that can be, the faster this occurs, and the more sugars that can be moved in speed, that's going to increase the size, and that's what it seems to do. It seems to influence the drive of sugars from the leaves, you know, so that is increasing the rate and also the conversion of sugars into starch. So with it's in the cell. So we have some the boron in it and some cobalt is the nutrients for, you know, stress ethylene, because ethylene will increase the abscisic acid in a plant. So we want to make sure that the plant is fully functional and that we have very rapid and a lot of sugar moving rapidly into the seed. This is the key area, and this is the key area. The gateway and the conversion.
So John,
basically what you're trying to do with that product is make it the pathway for the movement into the grain and to keep it in there.
Yeah.
Jocko's not on, but it's something similar that he has worked a fair bit with in the movement of filling potatoes before harvest and evening out the set size, even though you've got large and small, not sizing the big, but sizing up the little guys to end up with more middle size. So it's just controlling the movement of that sugar more so than trying to manage the plant hormonally, because that can get tough. As I said earlier, as Ed's going into this dry weather, if he has heat at pollination and tassel, he may need a boost of hormonal thing. If Rick's got 1.5 inches of rain on corn and it's got lots of moisture, and we're tasseling day after tomorrow and pollinating through the weekend and next week, we probably have a different type of stress in there that you don't want the same package. And there just isn't one be end all in the hormonal side. Plus you can get sideways of that fairly quickly also, right, John?
Yeah, hormones are very, very dangerous to use at this time. The best way is to make an environment where the plant will produce its own hormones in the right rate that it needs and the right proportion, because there's a lot of the hormonal activity in here is basically an auxin thing. But adding auxin to the plant doesn't necessarily mean you're going to move auxin. So it may interfere because there's crosstalk in here. There's a lot of, you know, where you talk about sizing, the plant is making its own gibberellic and balancing with, you know, cytokinins and auxins and a whole bunch of other things. It's very, very complicated because this just shows sugar movement, but there's the information from the endosperm to the embryo there's all this crosstalk taking place. Remember, it's this viable seed, you know, the seed that can reproduce. So it's extremely complicated, and we start monkeying with hormones, we can throw this off and cause some major damage, you know, shut the plant down.
John, when we first started reading up on this a couple months ago, you know, in the seed world, it was always of the mind to maintain a healthy plant to enable it to complete its grain filling period. You know, maintain a healthy plant throughout the grain filling period, and extend it so that the grain can continue filling naturally. But really, some of the what we've been reading talks more importantly about rate of growth, rate of grain versus length of grain filling period. It talks about the rate of growth.
Yeah, absolutely. And that's why we want to impact the leaves of the plant to drive those sugars out. So when you move sugar, the leaf will not produce any more sugars if it has been moved. So you have to produce the sugars, but you also have to move the sugars. If you don't move the sugars, it doesn't produce. And you got to remember, it's all about speeding this whole process up. So what we should do is we should see a crop that's senescing unisonally because we've impacted that crop, and we should see larger, heavier grain. Those are the two results. So the reason I have the two applications, one is primarily to influence to make sure that we have enough sugars so that we do not have seed abortion, which remember takes place in that first 2 weeks. And then the next thing is to make sure we have enough sugar and movement of those sugars in a rapid speeding it up so that we can accumulate more starch as we convert those sugars into starch and end up with heavier, larger grain. I mean, that's my story of sticking to it. But you know,
are we able?
What's that?
Are we able to mix it with fungicides?
Yes, actually, it would enhance the systemic fungicides. It's going to enhance the movement of those systemic fungicides into the leaf. It's going to enhance. It will enhance disease control because you have greater movement of those fungicides. It's designed to really go with fungicides. Because no one's going to ride just by themselves. They're going to ride with the two common fungicides, you know, that R1, DTR1 fungicides, and in the South they always put a second one in on that R3. So that's what they do.
What's the cost?
I have no idea. Whatever you can get, and then some more.
That's a good question, as a person would say. It calls under the to be determined, but it won't be over. It'll be a fair price. John and I are just finishing up the formulation on it, so it won't be an overly high-priced item.
Will we be able to put it on tomatoes to try to increase the sugar content and the size of the tomatoes? That would be a place to try it first.
No reason you couldn't, John, is there?
No, we'd have to adjust those rates slightly down because once again, the tomatoes, you're having a multiple fruiting crop, and if they're fresh tomatoes. Now we do have, and I've used this on processing tomatoes at this rate, and it's very successful there. It increases anthocyanins. It brings out the red color in that tomato. So you got to remember, at the rate that we're recommending, it's going to synchronize the senescence of that crop. And in field production, everything is about uniformity of emergence, uniformity, synchrony of pollination. So this is that same concept, taking it to that next level of synchronizing kernel development. So we don't have it all over the board. And that's where yield, uniformity is where yield comes from. Uniformity. If you got every plant in your field looking like your best plant, you're going to get yield. But it's all those poor plants that really suck it down.
John, you had mentioned preferably a split application. So a question to the folks on the call here: what's the reasonableness of expecting that we're going to apply twice?
Well, until it is proven, it's not going to be done. Just like the way we fertilized in the past. Okay. Until we see success, it's not going to be done. But there will be a few people that will have success. If I made an application and I got 40 bushels more, which we've seen naturally in how it can flex in seed size, we've already determined that, what the potential is, and we can control that, it'll be common. It'll be just as common as side dressing, just as common as wide drops are getting. So it's all about performance, you know.
So
Not
we've
worried
talked,
about that at all.
so we've talked about two things. We've talked about the science behind it. Then we've talked about a recommended product. So this is this is the direction we're heading for Thursday's presentation. I intentionally didn't send out the link for two reasons ahead of this call for the grower session. One is so we didn't get them mixed up with today's meeting. I had a couple of questions from the field on that, and the second was I wanted to leave room for discussion to make sure that there was that everybody was on board for having this Thursday call. So I'd like to hear back from the field, from just to your quick feedback. And I'll start with Don if I don't hear from anybody. And we'll just go around the room. Is this good? Need more education or not relevant?
I liked it because of the education part, that I can understand a little bit better what's going on. I don't have to know exactly the reasons why, but the understanding part is a big help, especially, putting it down to layman's terms for our customers. So appreciate that.
We'll keep going. Jeff?
In my mind, like Don said, the information is good. There's no doubt about that. It's very good information. The question that I wonder is it still something that's being researched? Do we need to have some data on it? Are we looking for more of the innovators instead of, the majority of people listening? Because as far as we get to the product, next what? Bioline, or the name of the product at the end there?
Nexus.
Bioline Nexus, yeah.
So when we get to that, I think that's more the innovators that'll pick up on trying that. So it's good information. You might lose some people, especially when you get to the end and start the application. Not everybody side dresses, so it's more the innovator, I think, that you'd have to look toward.
With regards of the newness of this information, the science behind it, the research that was all the material that we've been sourcing dates back to into the early 80s, late 70s. And John, you could speak to that a little more even.
Yeah, well, a lot of this understanding goes way back of movement and sugars, but Purdue did a lot of research in the early 2000s, I believe, that really brought it up about the accumulation of sugars and the understanding, because we always used to say, the longer the fill grain, the grain fill period, the better the weather at the end of the season, the better the crop. That's true. But that understanding of the rate of sugar accumulation is probably more important than the length of that sugar accumulation. And I've been working, I personally have been working on this concept for 10 years. And we so it's not, it's not far out. It's based on science, based on plant physiology, based on agronomy, and based on biology. So, there's no secret, no magic here. It just, the formulation is the tough part. You have no idea how critical that formulation is. So we have a formulation that looks very, very, very promising.
So may not be new science, but certainly new to, new bringing it to the field, I guess, because this type of discussion hasn't happened, at least in my years in the seed industry.
And the innovators are the first ones. I mean, how many people, when it came out to apply headline on corn, how many people did that? Very few. but is headline applied on corn or fungicides applied? Yeah. Even when there is no disease. So, acceptance is going to be based on performance, and you just hit a few home runs and it will grow,
We seem to be having trouble controlling the weather, but this is something we can control. I think that's a way to look at it as well.
Absolutely, and that's what these products are designed to address, the changing growing conditions, climate, or whatever you want to call it. The fact is that, if you've been at this a long time, it's not the same way it was when your dad farmed or your grandfather farmed. We know that, and we have to deal with it. Weather patterns are very extreme, hard to grow crops.
Alex.
I think it's a good presentation. It walks through kind of a portion of the crop that usually isn't discussed. As John kind of mentioned, people look at it and say, yeah, it's there, and then they just kind of turn their head away and don't pay attention to it anymore. So this kind of walks through what's actually happening during that section and then gives a management strategy at the end. So I like that.
Good. Rick? You might be muted, Rick. Yeah, you are. Okay, go on to Clay. Clay, you're muted as well. And then we'll go to Cheryl. Hey, Cheryl, you don't look like you're muted.
No, I don't appear to be, but I was.
Okay.
I think that if maybe a little bit more emphasis, if the idea behind most of the presentation, it's really good information, but the idea behind the presentation is to promote the product, and the main thing that the product is going to do is accelerate the sugar availability to the kernel. Maybe when we go through that particular slide that talks about that, a little more emphasis on that would maybe help a little bit. Yes, the yellow one. That might, because I paid a little bit of attention to that, but I kind of, yeah, okay, that's good, but it became apparent at the end why that was important. So maybe a little more leaning on that would be good. And what are G and F? And I like this stuff. What is it?
Glucose fructose.
Okay, thank you. Okay, that's what I think.
Good. Thanks, Cheryl. Ed?
Yeah, I find these sessions very helpful for me because I'm not as academically inclined or experienced as everyone else is. Similar to the side dressing or wide dropping comment, it took 11 or 12 years to develop that market, and we have the perfect platform to do that. So I'm anxious to get a few acres on and see what happens.
Yeah. Good. Yeah, this is all about lighting little brush fires and fanning them to build more momentum. So ideally, we would have had all of these presentations in January, February leading into the season, but we didn't. Here we are, so we're starting. And, building forward, these are all going to be updated and refined and really one of the main drivers for me anyways in having this session is it's good science, it's good learning, good education. I think everybody agrees with that. But the question I was asking right up front is good, but is there something that we can do to actually encourage or influence change? And it appears there is. So we have a we're putting together a product. So I'm interested to see where it goes as well. Clay and Rick, we didn't get a chance to hear from you or Jeff. Are you guys good with this? And not hearing anybody talk. Jeff, are you still on the line?
Yes, I did say something earlier.
Yeah, you must have been muted because we couldn't hear you.
No, earlier I did.
Okay, good.
Weren't you able to hear? Right after Dawn.
You're good to
But
go.
anyhow.
My apology.
Yep.
Then Clay. Clay, you just unmuted for a sec, then you muted again. There you go. You look like you're unmuted, Clay. Yeah, Clay must have some difficulty with his audio. I can see he's unmuted, but we can't hear him. Rick, any last comment from you? Okay, Rick's still muted. He could be dealing with something else. Ray and John, what's the probability of us having a price for Thursday, should the question come up? Or
Pretty high.
Do we need it for Thursday? Okay.
We can give you a range anyway.
Yeah, even a range is good. Yeah, just if it comes up on the call. All right. Well, I will get the invitation out here right after I get off of this call, so you can forward it on to growers. Short timeline, but I'm assuming that we're in regular communication with our growers. You know who it's going to be a fit for, and who we could, who would be interested in a call like this. So, John, I'm going to ask you to provide any closing comments, and Ray, I wouldn't mind if you would just close off the meeting here.
All I gotta say is, if you, this is your presentation. This is for the sales group. So if you have some points that you want me to put into it, please text it to me and let me know, and I will endeavor to incorporate them. So you're the ones that are out there trying to take the lead on this. This will make you a little different in the marketplace, and this is nothing to run away from. This is real stuff.
Good. Thank you. Ray, any last comments? I see you're muted there. So Ray might have got busy. Anyways, thank you very much, everybody. And John, I did find a little more material on comment that I think Jeff made, and Clay commented online as well, with regards to black layer. So I think I found a few good slides that helps illustrate the progression of black layer. Okay.
Okay. I appreciate that.
Thank you very much, folks. And we'll let everybody go.
Okay. Very good.
Thank you.
Bye, everyone.
Bye.
Ray just said he had technical difficulties, so.
Okay.
Thank you all.
Thank you.
From me.